Hello, my name is Anthony Ash, and I'm doing the hardware development.
I'm Ryan Riley, and I'm the hardware designer.
I'm Stephen Cummings, and I'm in charge of software development.
I'm Anthony Abraham, and I'm in charge of user interface design. And we are
OpenSourceECU.
Here we have a 3D representation of our engine. The object of this project, when it comes to hardware, is to remove this device. This is called a Megatron. That gives us solid state timing. And we plan to put in a Hall effect sensor, which will allow us to control the timing via a microcontroller.
Here we see the conditioning circuits for the OpenSourceECU. The above circuit receives input from the Hall effect sensor and conditions them to 5-volt pulses for the Arduino digital input. The Arduino processes the input and outputs that to the power circuit. The power circuit receives 5-volt output from the Arduino, which acts as a switch to supply 12 volts to the ignition coil, inducing spark at the rate of the RPM desired.
I'd like to give you guys now an overview of our system. Right here, as you can see, is the engine that we worked on. This is our test subject. The sensors involved here are our Hall effect sensor, and we also have a magnet pair that's located on the flywheel. From here, the signals are sent along this wire to our signal conditioning board. This sends and receives information from and to the Arduino. If you follow this over here, we now have our Arduino. This is the brains of our system. And back here we have our coil and spark plug pair. This is what sends our digital signal to a high voltage spark for our engine.
Now that you've seen our hardware, let's take a look at our system operation. Here we have the program to calculate our RPM. Based on how much time it takes to complete one rotation, the program will calculate the RPM. Using that RPM that we've calculated, we'll then come down to this program function that we've created that will fire the spark plug based on predetermined advances, so that we'll continue to keep our advance around 10 degrees past top dead center to allow for maximum efficiency on the motor.
Now we'd like to demonstrate the system as it operates in real time.
Now let's take a look at our user interface using LabVIEW.
The LabVIEW interface terminal allows the user to view the revolutions per minute output on a gauge and graph versus time. This is performed using a series of user read terminals and script conversion blocks.